All right, today we're going on a cosmic detective mission. Our goal? To hunt for life beyond Earth. And, our lead investigator isn't a person. It's a highly trained artificial intelligence, and its mission is to sift through thousands of distant worlds to find the ones that might just be habitable.
So what's the scale of this investigation? Well, get this. As of April 2025, astronomers have confirmed 5,867 exoplanets. That's planets orbiting other stars. That number is just incredible, but it also creates a monumental challenge for scientists.
Right, and that's the big question, isn't it? We've got this cosmic haystack with thousands and thousands of planets. So how in the world do we find the potential needles of life? How do we know where to even point our most powerful telescopes?
To even start answering that, we've got to understand why this is so unbelievably hard. It's not just about spotting a planet, it's about really getting to know it.
You see, the real work starts after a planet is found. We have to figure out its size, its mass, what it's made of, the kind of star it's orbiting, the whole shebang. And with thousands of them to check, scientists desperately needed a way to sort through them fast.
Okay, so what are we even looking for? What makes a planet a prime suspect for life? Well, scientists basically came up with a recipe, a super strict checklist of all the essential ingredients.
And here it is. The 7 key ingredients for a world that might look a little like Earth. For starters, it has to be rocky, not a gas giant like Jupiter. It needs a stable, almost circular orbit to keep the climate from going haywire. And, critically, it's got to have enough mass to hang onto an atmosphere. And of course, the big one. It has to be in the Goldilocks zone of a star like our sun. Not too hot, not too cold, but just right for liquid water.
So what happened when researchers took this super strict checklist and applied it to thousands of known exoplanets? The results were, well, they were stark. Worlds that are potentially habitable are incredibly rare. Less than 1% of all the planets we found meet every single one of these conditions. Yeah, get this. Out of 5,541 planets they analyzed, a mere 36 passed the test. 36. That's it. That is the needle in a haystack problem our AI detective was built to solve.
Okay, so with a problem that big, how do you even begin? Well, researchers turned to machine learning. They basically decided to train a sophisticated AI to become a world-class planet hunter, something that could spot these patterns way faster than any human ever could. And they didn't just use one AI. They brought in 2 of the best, each with a totally different style. Think of it like this. You've got random forest, which is kind of like a whole squad of detectives, all working the case at once and then voting on the answer. And then you've got XGBoost. He's more like that one lone genius detective who builds the case piece by piece, learning from every little mistake along the way.
So, first things first, the AI had to learn what clues actually matter. It looked at, a whole bunch of different data points, 32 of them, and used some clever stats to weed out the redundant stuff. It narrowed it all down to the 12 most important predictive factors, the ones you see here in blue. But here's the tricky part. The AI only had 36 good examples to learn from, compared to over 5,000 bad ones. If you're not careful, it could just learn to say, nope, not habitable every single time. So to fix that, they used this really cool technique called ROSE. It basically created, realistic synthetic examples of habitable planets, just to give the AI a balanced data set to train on and a fair shot at learning what to look for.
All right, so after all that prep work, picking the right clues, balancing the data, how did our AI detective do on its final exam? Well, the results are, honestly, they're pretty mind-blowing. Get ready for this. The XGBoost model, our lone detective, nailed an incredible 99.93% accuracy when it was tested on a bunch of planets it had never seen before. I mean, that's basically a perfect score. And this graph here, it's called an ROC curve, really shows you just how good it is. You see that almost perfect L shape up in the corner? That's what you're looking for. It means the AI is an absolute expert at telling the good guys from the bad guys, the habitable from the non-habitable planets. Let's break that down. This is like looking at the detective's final case file. In the test group, there were 9 planets that were actually habitable. And guess what? The AI found every single one. It didn't miss any. And for the non-habitable ones, out of more than 1,300, it only made 1 mistake, 1 false positive. That is an amazing track record. Okay, so now that astronomers have this incredible new tool, what's next?
I mean, this AI is a game changer, for sure, but the case isn't closed just yet.
Because here's the thing, the model is amazing, but it's only as good as the information you feed it. As the researchers point out, some planets are right on the borderline of being habitable, and for those, even a tiny little error in our measurements could make the AI change its mind.
And that really gets to the heart of what this AI is for. Its job isn't to give a final 100% guaranteed verdict. No, its real job is to be the ultimate sorting hat. It tells astronomers, hey, out of these thousands of worlds, these are the ones you should really be looking at. It helps us focus our most powerful telescopes where they'll have the biggest impact.
So at the end of the day, what this AI detective has given us is a treasure map. A really, really good one. It's a high-confidence, statistically verified list of prime targets for instruments like the James Webb Space Telescope. It's basically pointing the way. This whole statistical search has taken an impossibly huge task and made it manageable. Our AI detectives have given us the galaxy's most wanted list. And now comes the really exciting part. What will we find when we actually start digging?